Hi students, welcome to Maths Point of View. I know what you're thinking. The channel name is related to maths and we are learning physics. Don't worry. The channel name is not going to affect our learning. In YouTube, there are many channels which teaches physics, whether it is ICSE, CBSE or state. Then why you have to choose Maths Point of View? We have so many reasons. First thing, we are going to teach each and every chapter, including all the parts. If you take a force, chapter 4, there are 3 parts. We are going to teach every part. Not only that, whenever we are teaching a topic, for an example, moment of force, that is present in your first chapter. If I am teaching moment of force, I am going to teach you the questions which they have asked in the board till now based on this moment of force. So not only you are learning the concept, at the same time you are going to understand what type of questions they may ask you. They means the board may ask you in the exam. Once we teach the topic, we are not going to leave it there only. We are going to teach you each and every question which is there in your textbook exercise. So we are going to provide the solutions for all the questions which is there in your textbook. Okay, few students are very good at theory, but when it comes to numericals, they'll feel little afraid about it. So what we are going to do, we are going to solve each and every numerical which is there in your textbook, so that you learn the concept, you know how to solve the questions which is there in your textbook. Then we are going to solve all the numericals. Everything is done. Now, few topics in physics are difficult to understand without video or animation. We are going to include some animations to make the teaching effective. And one more thing. So when we are teaching each and every chapter part wise, if it is a very big chapter, we are going to divide the one chapter into many videos, and all the videos of all the chapters will be available in the description box of each and every video, so that you don't have to search for a concept. Just go for the description box. You will find all the videos chapter wise, and you can also find all the videos in our Maths Point of View channel as a playlist. Now I think you got the reason why you have to choose Maths Point of View for physics. Force definition is not that important, but effect of force on different kinds of body is very much important. Why? Because based on this topic you can easily expect 1 or 2 mark question. Now we'll jump into the topic. So effect of force on 2 different bodies. What are those 2 different bodies? One, a rigid body, one more is non-rigid body. These are the only 2 types of bodies. Now first we'll talk about only rigid bodies. In rigid bodies we have 2 types. One, rigid bodies with pivot point, rigid bodies without pivot point. Now you got a doubt, what do you mean by rigid body? Correct. So rigid bodies are nothing but a solids which are very strong, which are not flexible. So they are strong which are not flexible, very strong. So those are called rigid bodies. Okay, now we'll talk about rigid bodies without pivot point. What do you mean by that? So assume a solid. Okay, if you apply a sufficient force on it, what happens? It will move in one direction. Correct. So these kind of movement, that means movement of a body in one direction is called translatory motion or rectilinear motion. So this is an example for rigid body without a pivot point. Now you will get one more doubt. What do you mean by pivot point? Correct. Pivot point is nothing but a point on a solid which is fixed. Okay, which is fixed to a wall. Assume it is a wall which is fixed to a wall or a rigid support anywhere. Now if you apply a force, instead of moving, it will start rotating. Now you got the point, pivot point. Pivot point is a very simple thing. It is a fixed point on a solid which if you apply force on it perpendicularly, instead of moving, it will start rotating. So what are the 2 types of rigid body? Rigid body with pivot point, rigid body without pivot point. If you apply a force on rigid body without pivot point, instead of rotating, it will start moving. Why? Because it is free to move. What about rigid bodies with pivot point? Instead of moving, it will start rotating. Why? It is not free to move. Now we'll talk about non-rigid bodies. It is very simple thing. Compared to rigid body, it is very simple. Non-rigid bodies are not that strong and it is very flexible. So what do you mean by that? Take an example of sponge. Okay, if you apply a minimum force on sponge, what happens? It will move. I know, exactly like rigid bodies, it will move. Then after that, what happens? The size or shape or structure will also change. This is an example for non-rigid bodies. So the conclusion, there are two types of bodies: rigid body, non-rigid body. So what happens in rigid body? There are two types: rigid bodies with pivot point, without pivot point. What are the effects of force on rigid body with pivot point? It moves in one direction. Rigid body without pivot point, on applying force, instead of moving, it will start rotate. Why it is not moving? Why? Because it is not free to move. Now the effect of force on non-rigid body, what happens? It will also move, but the size or shape of the body will also change. Now we'll talk about moment of force or torque or turning effect of a body. All the three different words means the same. So in the exam you can expect these three words, but the answer will be same. Moment of force is nothing but torque. Torque is nothing but turning effect of a body. Now assume a body, any shape, okay, any shape. Assume a pivot point here. What you know what is pivot point, right? Pivot point is a fixed point where if you apply a force, instead of moving in one direction, it will rotate. Why it will rotate instead of moving? Why? Because it is not free to move. So this is the pivot point. What happens if you apply a force here in this direction? So assume this pivot point as A and this force as F. What happens? Instead of moving in one direction, it will start rotating. Why? We have a pivot point, fixed point. So what do you mean by moment of force? It is the product of magnitude of force. You should know the important terms in physics. What do you mean by magnitude? That is nothing but a number, numerical value. 15 Newton of force, all those numerical value is nothing but magnitude. Then one more thing, the perpendicular distance. In olden days, the potter used to rotate that potter wheel using a stick. So there was a pivot point. On that pivot point, if you apply a force, okay, it will start rotating. That is nothing but force. What about the perpendicular distance? The stick. How long is the stick? That is important. So moment of force. Moment of force depends upon two things. One is force, then one more is perpendicular distance. Force and perpendicular distance. Now using the formula, we can easily say what are the factors affecting moment of force. One, the first point is magnitude of force. How it is affecting? Both are in the numerator, correct? So you should know what is directly proportional and inversely proportional. All the physics basics are in the description box. So in physics there are few basics, directly proportional and meaning of few words. All those things are very much important. If you know that, then these concepts will be a piece of cake for you. So before learning this, learn those basics in physics. Now we'll talk about this one. Which are the factors affecting moment of force? Use this formula to answer this. First one, force, magnitude of force. What do you mean by magnitude? That just a number. Then perpendicular distance. Okay, so these are the factors affecting moment of force. Now we'll talk about units. Unit of moment of force. See, in the textbook they have explained many things. The important thing is what is moment of force, what are the factors affecting moment of force, and units. So now according to the formula, what is the unit of force? Newton. What is the unit of distance? Meter. So the unit of moment of force is Newton meter. This is the SI unit. Then what about CGS unit of moment of force? See, what is the CGS unit of Newton? It is dyne. So CGS unit of Newton is dyne. What is CGS unit of meter? That is centimeter. That's it. So what is the SI unit of moment of force or torque or turning effect of a body? Newton meter. That is the SI unit. CGS unit is dyne centimeter. That's it. Now we'll see clockwise and anti-clockwise movements in moment of force. It is very simple topic. Assume a body with a pivot point. You know what is pivot point. So If you apply a force in this direction, what happens? It will start rotating in this direction, correct? So what kind of direction it is? Anti-clockwise, correct? The direction of movement is anti-clockwise. This is nothing but anti-clockwise movement. And one thing you should keep in mind is anti-clockwise direction are always taken as positive movements. Anti-clockwise is always positive. Now take the same body with a pivot point, anywhere pivot point. If you apply a force in this direction, what happens? It will start rotating in this direction. So this is clockwise direction, correct? So this is nothing but clockwise movements. So clockwise movements are always taken as negative. Now we'll talk about some examples of moment of force. First example, take a door. Okay, in door there will be two corners, correct? One corner it is attached to a wall. In this attachment there will be a hinge, correct? Screw type hinges at the one corner of the door which is attached to the wall. Other corner, that is nothing but the opening side where you are going to pull or push to open or close the door, correct? So here this is very much important. In this hinges we are going to see moment of force. Now we'll talk about the first factor which is affecting the moment of force. What is that? Magnitude of force. What do you mean by magnitude? That is nothing but the numerical value. So here we are going to apply force to open or close the door, correct? Now which is the second factor? The perpendicular distance. This is very much important. Students will get doubts here only, but it is a very simple concept. Listen, what do you mean by perpendicular distance? You are applying force here. What is perpendicular to that? Here, correct? In this way, correct? So this is nothing but the perpendicular distance. If this perpendicular distance is more from the hinge to the point where we are going to apply force, if that distance is very large, then you require very less amount of force to open or close a door. If the distance between the hinge and the force where you are going to apply is very small, then you have to apply more force. Assume this is the handle which we use to open the door or close the door, which is near to this hinge. Then it is very difficult to open close the door. Difficult means we need to apply more force instead of applying a small force. Now we'll talk about the second example, which is spanner. Okay, so here we are going to turn a body, correct? Where we are applying force here, correct? We are applying force here and the body will rotate here. So what about the perpendicular distance? This one. So if the perpendicular distance is more, then moment of force is more. What do you mean by moment of force is more? That means you are going to apply less force to turn a body. Next example is steering wheel. Assume a steering wheel. Okay, now we are going to hold the steering wheel here, right? That means we are going to apply a force. Now what do you mean by perpendicular distance? Below this point, okay, exactly at this point, below this there will be a rod, correct, that is connected to wheels. That is not the perpendicular distance we are talking about. The perpendicular distance is this diameter. If this diameter is more, that means we are going to apply a less force to rotate the steering wheel. So these are the examples for moment of force. Now we'll see the questions which they have asked in board exams till now based on moment of force. This question was asked in 2020 for 2 marks. Define moment of force. What do you mean by moment of force? Moment of force is a product of F into D. You cannot write this as a definition. So how can we write this? Moment of force is a product of magnitude of force and the perpendicular distance. If you write like this, you will get full marks. So next, what is the relation between the SI unit and CGS unit of moment of force? Very simple. What is the SI unit? Newton meter. This is the SI unit. What is the CGS unit? That is dyne centimeter. This is the CGS unit. But are they asking which is SI unit and which is CGS unit? No. What is the relation between Newton meter and dyne centimeter? Remember, very simple. 1 Newton meter is equal to 10 power 7 dyne centimeter. How we got this one? Very simple. 1 Newton is equal to 10 power 5 dyne, and 1 meter is equal to 10 power 2 centimeter. So we have Newton and also meter. 1 Newton is equal to 10 power 5, 1 meter is equal to 10 power 2 centimeter. So together we have 1 Newton meter is equal to 10 power 7 dyne centimeter. This was asked for 2 marks. Now this question was asked in 2023 for 2 marks, and it is a very easy question, application oriented question. What do you mean by application oriented question? Whatever you have learnt in theory, you are going to apply in these kind of questions. First we'll understand the question. There is a body with a pivot point O and there are 2 points A and B. There are 3 forces are acting at B, and the condition is all the 3 forces are equal in magnitude. What do you mean by that? If the force 1 is 10 Newton, all the 3 forces will be 10 Newton only. If the force F1 is 50 Newtons, all the 3 forces will be 50 Newtons only. Now the question is, which among these 3 forces will have maximum moment? What do you mean by maximum moment? Which forces, okay, in these forces, which force will produce maximum turning effect? So the answer is very simple, F1. Why F1? The important thing about moment of force is perpendicular distance, because all the 3 forces are equal. So force is one of the factor, but all the 3 forces are equal. Then which is left? Perpendicular distance. If the perpendicular distance, see, perpendicular distance means the point where we are applying force from that to this one, okay, from that to this one, this is maximum. How can we say it is maximum? If the perpendicular force F1, okay, is 90 degree to a pivot point, 90 degree, correct? So from here, from this point, see, in this angle to this point, it is forming a 90 degree. If this force is forming a 90 degree, then it will have maximum moment of force. Okay, now what about F2 and F3? See, in this direction, the force is applying in this direction from here to here. See this angle. Do you think it is 90? It is more than 90. It is not like more the angle, more will be the moment of force. No, 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 no. 90 degree. Okay, what about this one? See, from here to here, again it is more than 90, correct? So which is providing 90 degree? Right angle, F1. Now I am going to explain you a simple topic, but I am not going to tell you the name. You know why? Why? Because first if I explain it and then if I tell the name, you can keep the name for a longer period of time. So first I'll explain it. Very simple thing. Listen. Whenever there is a rotating part, that is nothing but turning effect, moment of force will be there. Take an example of water tap. Okay, if you turn a water tap, there is a turning effect, correct? Then steering wheel, there is a turning effect. Then what about this one? Lock and key. Okay, then opening a bottle or closing a bottle. In all these 4 examples, we can see a turning effect, correct? Do you think the turning effect is produced only because of one force? Which is that one force? Externally applied force. That means we are applying a force, right? We are applying a force to rotate it or turn it. Do you think that is only because of only one force? No, there are actually 2 forces. One which we are applying, that is called as externally applied force. The one more thing is reactional force. Reactional force. We are applying a force, because of that force there is a reaction. That reactional force is one more force which we are talking about. So whenever we have a turning effect, we have 2 kinds of forces, correct? One externally applied force, one more the reactional force. So there is a pair of forces, but these 2 forces are in opposite direction. Okay, are in opposite direction, but they have same magnitude. So what do you mean by same magnitude? If I am applying 10 Newton force, so externally applied force is 10 Newton, then the reaction force will also be 10 Newton. So assume a tap, okay, tap, the rotating part, and this one, steering wheel, okay, and lock and key examples, you can take anything. Now we'll talk about moment of couple formula. Moment of couple formula, that is nothing but F into D. Okay, now according to moment of couple, it is defined as force into perpendicular distance. First we'll talk about this force. Okay, during the explanation I told you there are two forces, correct? Then which force value we have to apply here? You can apply any one force value. Why? Because both the forces are opposite in direction but they are equal in magnitude. What do you mean by equal in magnitude? If externally applied force is 10 Newton, then reaction force is also 10 Newton. They have same value. So you can apply any one force. Then this perpendicular distance, this is important. Which perpendicular distance we are talking about? Listen. Assume this is the cap of a tap water, okay, where you are going to rotate it to stop or open the tap. Listen, here you are going to apply, right? So are we talking about this perpendicular distance? No, this perpendicular distance from here to here, this distance is nothing but that perpendicular distance. The same thing in this case. Now listen, so this is the pivot point, correct? In the below this pivot point, a rod will be there which will be connected to the chassis or wheel of the car, correct? Are we talking about that distance? No, the perpendicular distance is nothing but, this perpendicular distance is nothing but the diameter of the steering wheel. Now you got to know there are two forces, any one force value you can apply here, and what is that perpendicular distance. Okay, now we'll talk about the SI unit, okay, unit of moment of couple. So what is the SI unit? Listen, very simple. What is the SI unit of force? That is Newton. And what is the SI unit of distance? That is meter. So this is how you derive a SI unit. Next, we need CGS unit also. CGS unit also. So what is the CGS unit of Newton? That is dyne, correct? What is the CGS unit of meter? That is centimeter. So what is the SI unit of moment of couple? Newton meter. What is the CGS unit of moment of couple? It is dyne centimeter. Moment of force and moment of couple have the same formula, so they have same units also. I think in one of the years they have asked one question based on moment of couple, okay, that is for 2 marks. The question is very simple. Define moment of couple and its SI unit. See how simple is it? If you understand the concept, you can aramse define it. See, in physics we don't expect for the exact definition which is given in the textbook. You have to use the keywords. What are the keywords? A pair of forces. What are those pair of forces? Externally applied force and the reactional force. They are opposite in direction and equal in magnitude, and these pair of forces are called couple. That's it. If you can define like this, that is enough. So definition is done. What is the SI unit? Newton meter. CGS unit? Dyne centimeter. You know about the conversion. That's it about moment of couple and couple. Now we'll talk about one more easiest topic and which is very much important, that is called as equilibrium. Okay, assume there are many forces acting on an object. Okay, if this object, even though there are forces, this object will stay in its state of rest or motion. What do you mean by that? If you apply forces in all the direction, so if it is at rest, it will stay at rest. Okay, if it is moving, it will keep on moving even though there is an opposite force. I'll give you one example. Now assume an object on a table. Okay, an object on a table. Assume you are going to apply force in this direction and one more force in this direction, but the condition is these two forces should be equal in magnitude. Assume 10 Newton and 10 Newton force you are applying in both the direction. Do you think this object will move? No, it will stay in its original position only. Why? Because the forces are equal but they are in opposite in direction. So now we'll understand the meaning of equilibrium. Even though there are many number of forces acting on an object, the state of motion of the object remains in the same state. If it is at rest, it will be at rest. If it is moving, it will keep on moving. So based on this equilibrium, we have two types. One is static, one more is dynamic. So as the name suggests, static means stationary, which is not moving. This is an example. What about dynamic? Dynamic means moving. First we'll talk about static completely. Okay, assume one more example. Okay, now assume if you keep any book or any object on a table, do you think it is going to move by itself? No, correct. Why? It is in the same state of motion. Do you think there is only one force? No, there are actually two forces. One, due to its weight in downward direction, one more force will be applied by the table on the book which has same magnitude. So there are two forces. So there are two forces but they are equal but in opposite direction. That is why this object is not moving. This is nothing but Newton's third law also. Okay, now we'll talk about dynamic equilibrium. What did I tell? Even though you are applying force in opposite direction, the state of motion of a body remains in the same state. If it is at rest, it will be at rest. If it is moving, it will keep on moving. I'll give you one example. Raindrops. Okay, so raindrops will fall downwards from sky to our earth, correct? This will be in downward direction due to its weight. Don't you think there will be one more force which will be in opposite direction? That is because of buoyant force of the air. Okay, there is one more force which will be in opposite direction. That is because of buoyant force. So how do you represent buoyant force? FB. Okay, now we'll take one more example. Okay, airplane. During the takeoff, okay, it will go in upward direction, correct? It will go in upward direction. Don't you think there will be one more force which will be pulling the plane in downward direction? That is nothing but weight of the plane. So even though there is a force which is opposite to the motion of plane, the plane will go in upward direction only. If it is moving upward direction, even though there is a force, it will stay in the same state of motion. That is nothing but equilibrium. Equilibrium is nothing but whenever there are many forces acting on an object, if it is at rest, it will stay at rest only. If it is at motion, okay, if it is a linear motion or rotational motion, okay, it will be in the same state of motion only. That is nothing but equilibrium. Now we'll talk about most important topic of this fourth chapter. Why? Because it will give you 4 marks easily within a minute if you know the logic. So these numericals are not that complicated compared to electricity and calorimetry. Very simple numericals, but you should know the logic. Okay, that concept is nothing but principle of movements. Principle of movements will tell you, listen, anti-clockwise direction. Anti-clockwise movements equal to clockwise movements. What do you mean by this? Okay, we'll understand this one with an example. Assume there is a scale. So this is how they'll give you numericals. Listen, there is a scale and it is uniform meter scale. They will give you this word, uniform meter scale. So first we'll talk about meter scale. What do you mean by meter scale? It will start from 0 centimeter to 100 centimeter. Okay, what do you mean by uniform then? If you take any point between 0 to 100, the weight of the scale at that point will be equal to any other point on the scale. if at this point, okay, assume 20, here if it is 5 grams, if you take at 70 also, at that point the weight of the scale will be 5 grams only. Okay, that is nothing but uniform meter scale. Okay, now how can we solve the numericals using the principle of moments? What is principle of moments? Anti-clockwise moments is equal to clockwise moments. First we'll talk about a fulcrum. Fulcrum. What do you mean by fulcrum? The point at which the scale can be balanced without any loads, okay, on it. Listen, assume, so if it is uniform meter, it will be exactly at 50 centimeter. Uniform means it will be exactly at 50. Okay, if you keep a scale and a very sharp object, you can keep it at 50 and the scale will get balanced by itself. That is nothing but uniform meter scale. So at 50 it will balance itself. Now assume I'm going to add a load here. I'm going to add a load of 40 GF. What do you mean by 40 GF? If I tell you 40 grams, okay, 40 G, that is nothing but 40 grams. What is this GF? GF is nothing but the unit of weight. Gram is nothing but unit of mass. So don't get confused. Mass is equal to weight only, but weight depends upon the acceleration due to gravity. If we are talking about this point, okay, here mass will be equal to weight. If you take the same object in a different place, mass will not be equal to weight. Okay, so 40 GF is equal to 40 grams only. Don't worry about that. Okay, I'm going to keep this load exactly at 20 centimeter. 20 centimeter. Now do you think the scale is going to rotate in clockwise direction or anti-clockwise direction? So we have the load here, right? So it will go in this direction only. If it is going in this direction, what kind of direction is this? Anti-clockwise direction, correct? So anti-clockwise moments mean moment of a scale or anything in anti-clockwise direction due to the load. Now here, now we'll talk about the clockwise moments. Now I'm going to keep one more object, okay, one more object at 80. At 80 the load is 20 GF. Assume the load is 20 GF. You can take any load. 40 and 20 is not compulsory, and this point 20 and 80 is not compulsory. You can keep load at any point. Any load is fine. Now what happens here? So assume this load is not there, okay, assume this load is not there and only this one is there. So this will go in this direction. See, this is going in this direction. Okay, what kind of direction is this? Clockwise direction. So clockwise movement of any object, okay, due to load is called clockwise movements. So how can you find the value of it? Okay, what do you mean by principle of movement? Principle of movements is nothing but anti-clockwise movements is equal to clockwise movements. For that we have a formula. What is that? W1 into x1 is equal to W2 into x2. Okay, first we need to understand what is W1 and x1, W2 and x2. W1 and W2 will represent the weights of two loads. X1 and x2 will represent the distance between 2 points. Which are those 2 points? See, if I am talking about x1 or x2, there are 2 points, correct? In those 2 points, fulcrum is compulsory. Fulcrum is compulsory and all the distances, okay, will be calculated from the fulcrum. What do you mean by fulcrum? The point at which where you can balance the load, that is at 50 centimeter. So all the distances are calculated from 50 centimeter, that is fulcrum. Okay, now listen here. So from here, what is the distance? 40, 30 and this is 20, correct? So 10, 20, 30. 10, 20, 30. So x1 value is 30. What is the value of W1? What is the value of W1? 40 GF. You can write it directly. Okay. Now, what is the weight of W2? What is the value of W2? 20 GF. W2 is load. So that is 20 into. What is the value of x2? Okay, listen. From 50, I told you all these values are calculated from the fulcrum here to here. So from 50 to 60, 10, 70, 20, 80, 30, correct? So what is the value of x2? That is 30. Now Listen, for 3s are 12, for 2 zeros I'll write 2 zeros, 3 2s are 6. Okay, so for 2 zeros, 2 zeros. Do you think these two are equal? No, these two are not equal. Then what happens? See, what do you mean by they are not equal, and what if they are equal? If you get an answer, if both the sides LHS and RHS are not equal, that means this load is not going to get balanced. There will be no balance. Okay, either it will rotate in clockwise direction or anti-clockwise direction. How can we say whether it is anti-clockwise or clockwise? Which side has a more value? LHS, correct? LHS is anti-clockwise movements. So this side has more value, so this will rotate in anti-clockwise movements. Okay, now assume both the sides I got the same answer, 1200 and 1200. Then the scale will get balanced even though you have load. See, the weight of the load and the distance of the load will not matter. Even though there is change in weight and the distance, you can easily balance the scale, but the condition is both the sides you should get the same answer. See, this question is compulsory for 4 marks. Okay, not this question exactly. There are many types of question. From 2017 till now, they have asked 4 times this numerical, not this numerical, different kind of numerical based on this topic, 4 times for 4 marks. All the 4 questions if I teach now, you will get little confused. Why? Because we have all the numericals in the numerical section, correct? I told you earlier, once we teach all the topics in the part A, we are going to solve all the questions in exercise 1A, the complete theoretical problems. After solving that, we have numericals. MCQs answers are given in there itself, but numericals answers are given, but we don't know how to solve it, correct? So once we complete all the theory problems, we are going to solve all the numericals step by step, so these numericals are around it will start from 8th question. But what about first 8 questions? Those are also important, so we'll go step by step. Okay, so we are going to solve all the theory questions and also all the numerical questions, but in a different videos. Okay, this is from part A of force part A. In the description box you can find all the chapters videos in the description. In the next video we will see how to solve theoretical problems which is given in exercise 1A. That video will be available in the description box.